Hey, it's Mr. Allred here, and I want to talk about composite functions. We've done piecewise functions and combining functions, but composite functions is a little bit different, so make sure you pay attention here. The thing that kind of separates it, or the way to remember it, is a composite function is one function that uses another function as its input. So down here we see f, and then we have the parentheses, which usually shows us the input. We see that this function f has an input inside those parentheses of g. And g may have its own input since it's a separate function. So this is what we mean by composite function. Not just adding two functions together or multiplying them, but using one to become the input of the other. This notation over here on the right reads, let's see, what does it read like? It might say f of g of x in this case. So basically these things read from right to left. In this case, x goes into g, but then that function goes into f. So these two notations mean the same thing. But let's see it used. So down here we have the examples. We have f of x equals 7x minus 8, and we have g of x equals negative 6x plus 2. So what we're asked to find here is f of g of x. And since we don't have a value for x, that means we're just going to treat g as the input of f. So the way I usually do this is I start writing out f, which is 7x minus 8. So I put the 7, then I leave a placeholder, big old parentheses, minus 8. So 7 with an m times an input minus 8. And that input would be g, which is negative 6x plus 2. Now we could do some cleanup here. We could definitely do some distributive property. Negative 42x plus 14 minus 8, and if we clean that up we'll have negative 42x plus 6. So basically what we did was we took two functions that calculate numbers separately and combined them into one. So I like to think of this as we pass something to g, get a result, and then pass that result to f. Okay, as we'll see in a little bit. But let's go ahead and do some more composites. So here, this example, f of x is x squared plus 5x minus 4, and the g of x is 3 minus 2x. So the first time we want to do this, we're going to try and find f of g, which means g is going to go into f. So keep that in mind, g is going to go into f. So I'm going to write down my f, which is x squared. So I'm going to put a parentheses there with a square as a placeholder, plus 5 times a parentheses for a placeholder minus 4. So f has more than one x in it, so each one of those is a placeholder for an input variable. And what we're going to place in there is the g's, which is 3 minus 2x. And I guess we have time to clean this up if we like. Let's see. We don't necessarily have to clean it up, but let's see. If we square 3 minus 2x, we'll get 9 minus 12x plus 4x squared. I'm going to take a moment to make sure I didn't mess that up. I feel confident. I'm going to distribute the 5 through the 3 minus 2x, so plus 15 minus 10x. And then minus 4. So if I collect like terms and order the polynomial, I'll have 4x squared, and I'll have negative 2x, and then let's see, a little bit here. So there's a constant. So that looks like it would be 11 plus 9 plus 20. Somehow I switched to a different color there, but here is the x squared, the x, And then so, oh, I see something. My two x's were both negative, so that should be minus 22. Okay, so let's, come on, eraser. That's what happens when I clean up. So my when I collect like terms, it should be 4x squared minus 22x plus 20. Okay, I didn't see that extra sign there, so hopefully that's right. If you catch something, let me know. But we just did f of g. Now what we want to do in the next one is do g of f, which can be very different. A few times they may be the same, but you shouldn't expect them to be the same. So let's see here. G. So we're going to write down g, which is 3 minus 2x. I leave a placeholder for where the x would be. And what I'm going to plug in there this time is f, which was x squared plus 5x minus 4. And if that's the case, I'm going to clean it up by doing some distributing. So let's see. 3 minus 2x squared minus 10x plus 8. So when I clean all that up, I'll have negative 2x squared minus 10x plus 11. So that's g of f, which is very different than f of g. Okay? And that's just finding the function. So let's see how we evaluate these things. I'm going to use the same functions. F of x equals x squared plus 5x minus 4, and g of x equals 3 minus 2x. So I'm going to do a couple things here. I've got f of g of 3. So remember what I said. This is the same thing as f that takes g of 3 as an input. So what I could do is I could go back to what I had just calculated, which was 4x squared minus 22x plus 20. Oops, excuse me. 4x squared minus 22x plus 20. And I could plug the 3 in there. And if I do, let's see what I get. I get 4 times 3 squared would be 4 times 9, 36. Minus 3 times 22, which would be minus 66 plus 20. So it looks like that would be 56 minus 66, so it would be a minus 10. Now that is the fact that I already had the composite function. But let's go and let's kind of do the same thing off to the side and do it a little bit differently up above. So one thing I talked about here was I need to find g of 3 if I do it a little bit differently. So if I do that, it would be 3 minus 2 times 3, which would be 3 minus 6, so minus 3. So basically, if I continue on my first line, f of g of 3, I would be doing f of negative 3. And then we would take that negative 3 and plug it in for f. And let's see if we get the same thing. So in this case, I get 9 minus 15 minus 4. So that's minus 19 and a positive 9, so minus 10. So what you see is whether we do it using the composite function already taken care of, which was the 4x squared minus 22x plus 20, whether we use the function that we already found, we get negative 10, or if we use it as a series of one function then the next function calculating, we get the negative 10 as well. So let's do that again with the next example I have, which was g of f of negative 2. So let's just see what happens here. If I'm doing this, it reads from right to left. So I'm trying to find g of f of negative 2. So if I come over, let's wait on the PowerPoint to catch up. Okay, there it is. So I need f of negative 2. So in that case, if I come up to f, that means negative 2 will go into the x squared plus 5x minus 4. So that's 4 minus 4, so that gives me negative 10 as well, it looks like. But we're not done with it. So f of negative 2 was negative 10, so now I'm trying to find g of negative 10. So when I figured out what f of negative 2 was, I'm going to take it and plug it into g. And in this case, that'll be 3 minus 2 times negative 10, so it'll be 3 plus 20, so it looks like I get 23. Let's see. We'll use some different notation here, or colors at least. So let's go back to what we had when we found the function for g of f. It was negative 2x squared minus 10x plus 11. Let's see if I can remember that long enough to write it. Negative 2x squared minus 10x plus 11. Minus 10x plus 11. So I'm going to plug the negative 2 in there. So I only have to plug it in one place. But let's see here. If I plug the negative 2 in, I will have negative 2 times 4, negative 10 times negative 2 plus 11. So I got negative 8 plus 20 plus 11. So in this case, let's make sure everything's right. If I haven't made a mistake, that's 31 minus 8, so 23. Okay. So in there, we eventually got the same thing without dragging it out as long as we did. Okay. So the composite function takes one function and plugs into the other. But in this case, if you actually have a value, you could plug that value into the composite, or you could follow it through the making of the composite. Alright, so let's talk about domain issues here. So I'm going to look at these two functions. F of x equals the square root of 4x minus 3, and g of x equals 6 over x minus 7. So each one of these has their own domain. If we look at the domain of f, comes from saying the 4x minus 3 greater than or equal to 0. So x is greater than or equal to 3/4. And the domain of g comes from saying the denominator not equal to 0. So x cannot be 7. Okay, so each one of these functions we're going to build a composite function from has limitations. So first of all, let's just go ahead and let's write out our f of g. So f is the square root of 4 times a placeholder minus 3. And in that placeholder, we're going to put 6 over x minus 7. Okay. So if I clean that up just a little bit, just trying to make it look a little bit better, I'll have 24 over x minus 7 and then minus 3 all under the root. So a couple things there we got to figure out is how can we talk about the domain of this thing? Well, we got to come down here because first of all we can't use anything that didn't work in the original functions. So 7 is out, anything less than 3/4 is out. But we've got this root here, so let's see. Nothing under the root can be negative, so we'll set up a rational equation. 24 over x minus 7 minus 3 equals 0. So we can pull the 3 over, multiply top and bottom by x minus 7. And the new equation we get out of that would be 24 equals 3x minus 21. So if I bring this over, that would be 45 equals 3x. Excuse me, so this thing should be greater than or equal to 0. So we get x is less than or equal to, what happens here? 15. Kind of a surprise for us. But that means we can only use numbers greater than 15 now. Excuse me, x is less than or equal to 15. So it has to be less than 15, but it can't be 7, because of the rational function, and it can't be greater than, it has to be greater than 3/4. Okay. So we're kind of stuck